Okay, so ladies and gentlemen, if we're going to make MacRip burgers. All right, now MacRip burgers are not from that silly McDonald's, you know.
They're from Mac's.
This is not an Irish thing. This is a Scottish thing. All right, and so I've started a new chain of burgers. Now, what do we need to make a burger? What's the first thing?
You need some meat.
You need a bun. You need a bun.
First, you need a bun. Okay. Then, what do we have next?
You got some meat.
Mayonnaise.
You need
Okay,
condiments.
hold on. Wait a minute. Okay, so let's put a piece of lettuce in first. Gotta have lettuce. Gotta have. All right. Okay, come on. We could waste 20 minutes listening to you guys talk. It's up to you. All right. So then we're gonna put some meat. Okay, good. Is it gonna be a single or a double? Just a single?
No.
You gotta stack that up.
Wait, can we triple?
5 guys. Yeah.
All right. Now, so what's next? On top of the meat?
Cheese.
Cheese. Okay, some good cheddar cheese. What's next?
Tomatoes.
Tomatoes. Okay.
Bacon. We forgot the
Oh yeah, bacon.
Tomatoes.
Bacon.
Okay. Then what would bacon be? Bacon would be blue. All right, so bacon,
Can we get some onions?
onions.
Oh.
Sauteed
No,
onions,
no.
not raw onions.
Oh, sauteed onions.
Yes.
Very nice. Okay. What else we got? We gotta have the secret sauce. All right, so the secret sauce. And finally, we're going to put the top bun on. We're going to make this a single, not a double. All right? It looks pretty decent size. I mean, that's a decent looking burger, right? All right, so here's the way these things are going to be done. What they're going to do is you're going to make MacRip burgers. You're going to make them in an assembly line fashion. All right? So there'll be 3 people, and each person's job will be to do part of the burger, and then you'll pass it along to the next person. Good so far? Okay? So the first person's job will be to take care of the bun and the lettuce and the meat. Okay? So person number 1 is going to be bun plus lettuce plus meat. All right? Now, when they get done, have they finished a MacRip burger?
No.
No. But what they've done is they've created an intermediate. All right? Intermediate. All right, so this is the first step. Now, what are we then going to do? We're going to pass it along to the second person, pass the intermediate along to the second person, and what are they going to do? They're going to add the cheese and the,
I don't know what that
that's a tomato, I think, and the
Bacon.
lovely blue bacon. All right?
Wait, are we making like chemical abbreviations for the food?
No, I'm just picking letters so it's something to write down. That's just rather than writing all those words out. Now, am I finished making a burger?
No.
No. All right. So now instead of having intermediate number 1 to distinguish, we're going to say this is intermediate number 2. So intermediate number 2 is then combined with, what was that? Oh, sauteed onions. Yum. All right. The secret sauce, ketchup and mayonnaise mixed together, and the other bun.
Isn't that just called fry sauce?
So what have we made? We've made a MacRip. All right, so there's your 1 MacRip burger. All right, does that make sense?
Yeah.
Now, in a perfect world on an assembly line, what happens? How fast does each person work?
Very fast.
At the same, not very fast, but at the same rate, right?
Yeah.
So when we've got 3 really good people kicking along here all at the same time, we can just get this thing done. You know, the first guy slaps the 3 parts together, second person slaps the other 3 parts on, third person slaps 3 parts onto that, and boom, we've got a burger. And we're just cranking along. Maybe we're knocking out, what do you think, about 6 of these a minute? All right? Because it's like, we're sitting there and all of a sudden, you know, the team bus comes in and they've got 60 people who've all been at a track meet for 8 hours. They're all starving to death and they all want burgers. All right? So we're pushing them out as fast as we can because if there's like 60 people on the bus, it's still going to take us 10 minutes just to get the burgers out for them. Right? So we're cranking out 6 burgers a minute. Now, that's great if you have your usual crew together. So we got your usual crew together, and these guys work, all 3 of them work at the same rate, and they do a great job. Nobody's slowing the process down. Things are kicking right along. Then what happens? Somebody calls in sick. All right? So let's say this guy, the one that does the last step, calls in sick. All right? And to replace them, we replace that person with a manager. Which you know, if you've ever worked with managers, they're slow. They're not efficient. They're rude? Okay, they're rude. All right? So what's going to happen to the whole process if we put the manager in here? It's going to slow the whole thing down. If this is the slow step, that's going to slow everything else. Everything else is going to do what? It's going to back up. Isn't it?
Yeah.
I mean, so if this guy's cranking them out, pushing them out really fast, this one's grabbing them, cranking them out really fast, and then this guy, you know, there's going to be a pile of things up to this level sitting there waiting on this manager to get his butt in gear. Right? On the other hand, if the slow step were this one, what's going to happen to these other two guys? Well, do they necessarily have to slow down? They will go as fast as they can go. As soon as one gets there, they'll still go at their 6 burgers per minute, but they can't get 6 burgers per minute because they can't get enough from the first step. So if the first step is slow, the rate of this step is going to determine the rate of the entire process. Do you agree with that?
Yeah.
Okay? If this bottom step were slow, then the rate of this step would determine the entire process. So far, so good.
Yeah.
All right? So what we're saying then is that the whole idea of rate is based upon which step slows down the whole thing. If everybody were equal ability, we just crank through and there's, you know, the rate is determined by the entire process. If there is a slow step, that's going to determine the entire process. So what we said though, for instance, let's say with the manager was smack in the middle, what we're going to get is effectively, this is going to sort of almost reach an equilibrium because what's going to happen is some of these are going to fall apart while we're waiting for this guy to get to his step. You see where I'm coming from? You know, theoretically, this could almost reach equilibrium and some of these burger, lettuce, meat things could be falling apart or coming apart and we don't have them anymore just because we're waiting for this step to occur. So far, so good. All right? Now, so what we're saying from the videos, Noel, is they're saying, okay, how do we determine the rate? If it's just a one-step process, the rate is based on the individual pieces. Okay? So for instance, if we just say it's a one-step process, then it would be based on the concentrations of the things that were present. So if we just have A plus B going to AB, will it matter how much A is present? If this is the entirety of the process, A plus B goes to AB, will it matter how much A is there?
Yes.
I heard some no's and yeses, so let's think for a second. Let's go back to my stupid example that I've been using all year. Boys and girls make couples, yes? Does it matter how many boys are there? Will we make more couples if there are more boys?
Yes.
Will we make more couples if there are more girls?
Yes.
So will the concentration of both boys and girls matter?
Yes.
Does that make sense?
But it won't affect
Suck
the
it,
rate,
Jared, you were
will it?
wrong.
No, say it again.
It won't affect the rate though, would it?
Sure it will. Because if I'm looking to see how fast I can make couples, if there's only a few boys and they're scattered here and there, the girl's got to find them first. Then she's got to decide if he's worthy of her. And then maybe we can move forward. Right? I feel you. I was there all weekend. I slept right around the clock the last 2 days.
You know the goal.
All right. Now. What's that? All right, moving on. All right, so basically what you're saying, if it was a simple single-step process, then the rate would be based on each of the individual parts. So the rate in this case is going to be equal to the concentration of boys times the concentration of girls. Now, if the process is just a single step process, then this would be to the first, even though we don't normally write it, and this would be to the first, even though we don't normally write it. All right? Does that make sense? All right. So, now, here's where it gets a little weird. Most things aren't a single step process. Most things don't just happen in one step. And we don't know what's actually going on in the container. Okay? In most cases, we truthfully don't know exactly what happens in some chemistry. And we have to ascertain what's going on in the chemistry based on the rate and how it's affected by changing the various things. Okay? What do I mean by that? Let me show you based on this example. If we talk about this process, let's say there's another process where A plus B goes to AB, and then AB plus C goes to AC plus B. You okay with that? Simple two-step process. Now, if this is the slow step, then the rate of the whole thing will be based on the slow step, right? And so the rate for this particular one, I forgot the K over here. The rate for this particular would be some constant times concentration of A to the first, concentration of B to the first. You agree with that?
Wait, why is it different?
Okay, because there's only one A and one B reacting to make AB.
So it's the coefficient step.
So it's the coefficients give you the powers to which it's raised. Yes, sir.
How do you find what the K is?
Not yet. Give me a day. All right, the idea is you'd have to know, the only reason, obviously, that these two can't be equal is because rate is talking about changes over time or concentrations per time, and these are just concentrations, so we need a K to make them able to be equal. The K is the conversion factor between concentration and rate, so that we can actually set them equal. All right? Now, if on the other hand, this were the slow step, and this was an equilibrium, a fast equilibrium. All right? Now the rate would be based on all of these, both A and B and C. All right? So now it would matter whether there's any C present. In other words, let me say it this way. If this first step is the slow step, the amount of C you put in there won't matter at all as to how fast the rate, what the rate is, rather. Let me say that again. If this is the slow step, if this blue process is the slow step, the first one, then the rate will be strictly based on A and B, and you can dump as much C in as you want, and it isn't going to go any faster. Think about it this way. If this is the slow step, then it doesn't matter how much cheese you have. You could lay out as much cheese as you want, but until the manager gets his in gear and gets the this first intermediate created, nothing else is going to happen.
Could the C slow it down even more?
If you take out C,
No.
nope.
Could it slow it down more? Like, leave it in.
No. If we're saying here, we're trying to make AC. This is the process we're trying to undergo.
Yeah.
If this is the slow step, you can dump in all the C you want. It isn't going to go any faster. Okay? On the other hand, if this were the slow step, then the rate would be based on all three items. Because you'd need to, how fast you could get these two to react to make this, AB, and then the C would also matter. All right? So similarly, if this were the slow step, then it would matter how many buns, lettuce, meat you have, in addition to how much cheese, tomato, and bacon you have, as to how fast you could go. Does that make sense? We good? Sir?
So, like, let's not say the second one's slow, for the first one's slow. If I put more in B to where it could, like, would that affect the rate? Like, would it be, like, no longer slow? So then C would matter?
Okay, here's the thing. Amount versus rate, two different things. Okay? What we're saying is some things come together and happen easily, some things don't. Doesn't matter how much you put in. If this is slow, adding more A or B will speed it up more. All right? But it's still a slow process compared to this. So if what we're doing is doing comparative to the various steps. So for instance, if you go to another MacRip store and they've got really, 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 really good people that can crank out 12 burgers a minute, then all of a sudden, you being able to do the same thing, you're now the slow step. You've slowed their process down if I dump you into that store and you're used to doing 6 burgers a minute. All right? All right. Is that a good basics? All right, can you kill that? Yes, ma'am.